What's up, everyone? Buckle up for a new episode of Tech in Check. Let's dive into the basics and complexities of machinery maintenance with engineers Rich Marriage and Tony Planamento. Join us as we meet with guests from the marine and industrial world to learn about the latest technology that keeps your equipment in check and working for you.
Hello, I'm Tony Planamento. I'm the Technical Project Supervisor with AME. Welcome to another episode of Tech in Check. Today I'm here with Cory Burns from RDI, who's graciously agreed to sit down with us and tell us a little bit about what he does.
Thanks, Tony. Appreciate that. Cory Burns, the Southeast Sales Manager for RDI. Cover 7 states, North Carolina, Tennessee, South Carolina, Georgia, Florida, Alabama, and Mississippi. My background, I started my journey in vibration in an electric motor shop. From there, spent 9 years there. From there, went to a company called CSI, which was a vibration company, privately owned.
Oh yeah, we're familiar.
Emerson bought them out, and I stayed about a year after Emerson purchased CSI. Then I went to work in a plant. So I stayed at a paper organization for 10 years.
Okay.
As my kids were younger, just to be Coach Cory, be off the road. Yeah. So as they got older, I realized that I needed to make better money. So I knew I needed to get back out on the road as they were wanting to go to college. So from that point, I went back to a motor shop as a salesman for part of the time. And then I became the general manager of the shop for the other half of the time. And then shortly after that is when I got a call from RDI. And I have been here currently with RDI for 4.5 years now.
That kind of brings us into why you're here today, is just to kind of explain to everybody watching out there, what is RDI? What is this new limb of condition monitoring and vibration analysis that you guys are essentially growing?
Sure, yeah. So RDI stands for Research, Development, and Innovation, which, you hear a lot of acronyms out these days and not many people
AME.
Explain what they are. But we truly are that. And I think that you've probably seen some of that as well. The research, the development, the innovations.
Oh, yeah.
Motion amplification has never been around. It was invented by our CEO, Jeff Hay. This motion amplification was invented out of the University of Louisville. So Jeff originally wanted to be an astronomer. So motion amplification was invented to see the changing and movement of stars coupled to a telescope.
Cool. That's cool.
Yeah, coupled to a telescope. So Jeff brought it down to Earth and pointed it at a motor and a pump. And that's kind of what brings us all together here today. Wow. Short story.
So what would you say in layman's term is motion amplification, for maybe a little bit more detail than the actual title? Because I think that's almost self-explanatory.
Sure, yeah. So how the system works is we use every pixel in the camera and we turn that into a displacement sensor. So with high level of accuracy. So anytime you film something, you can extract, or what we call draw an ROI, a region of interest, and pull that vibration from anywhere in the video.
Based on those pixels.
That's right, yeah.
So for those who don't know, displacement means movement,
sure.
Right? Motion, physical motion. So how can you, in layman's terms, explain how they are able to detect that motion?
Sure, yeah, good question. So how motion amplification works is a pixel-to-pixel difference at a sub-pixel level. So you need some contrast between the two. So between that contrast and the movement of the pixels is how we can extract that data.
And correct me if I'm wrong, I think it has something to do with the light intensity. Is that correct?
It does as well.
Yeah.
Lighting has a lot to do with it.
Yeah,
for sure.
That establishes contrast, right?
Mm-hmm.
All right, so Cory, you told us about RDI and how it came to be and what it can do. Why don't you go ahead and give us some examples of some use cases?
Some use cases. Okay, so say that you have misalignment, right? So this is a common story in industry where you have an alignment crew goes out to align a piece of equipment, and they get the green thumbs up, the green that they're good on their tolerance.
Smiley face.
Yep, smiley faces, all that, whatever their instrument gives them. And then they leave and they start the machine up, and the vibration analyst comes behind them to make his check. Well, when he makes his check, he still sees misalignment in his vibration data, right?
Yeah.
So this is a constant thing. I have been a vibration analyst since 1994. This is something that was in place prior to me. This butting of heads, I guess you could say.
It's tribal.
Yeah, and I on my 4th demo at a steel mill, I saw this in real action. So the vibration analyst calls me in. We have our presentation with he and his manager, and then we go out to demonstrate the product, and he brings me straight to one fan right outside of his office, right? So, and that's the only thing that he wants to check. So we take some shots of the fan, we go back in the conference room, sit down, the manager's in there, and there's 2 other individuals in there that at the time I didn't know, but it was the guys that did the alignment. Yeah, so I pull up the first video, and you see this was a motor fan combination sitting on spring isolators. Okay. So the back of the motor is just popping up, right? So here's your 2 times smack that your alignment, your vibration is seeing.
Yep.
Right. And as soon as I pulled it up, the 2 alignment guys said, "That's it right there."
I told you.
Yeah, so I had no clue about all of this prior. So walking out of the room, my contact said to me, "Cory, that's the first time we've had a civil conversation about that fan," right? So with motion amplification, I think it brings you to the solution a lot faster. Okay,
Yeah.
We use all these technologies, and we're looking for the fastest solution to relay to our customer.
And get to the root cause.
That's right.
Yeah.
And I think motion amplification pulls you there a lot quickly. I saw where it was a huge communication source between the alignment crew and the vibration guy.
Yep.
Since then, they have meshed with each other and they get along a lot better. The
RDI, making the world a better place.
Hey, it's communication, right? Seeing is believing.
Seeing is believing. I was just going to bring that up.
That's right.
That's your catchphrase, right?
That's right. Yeah.
No, I mean, that really helps us out a lot too, because as a vibration analysis company, we can show you squiggly lines on a chart all day long until we're blue in the face. But the second we can show you a video and say, "Look, this bass is doing this," they're like, "Oh, okay." It really helps to that communication factor, like you said.
Yeah, it drives for the correction.
Yeah.
So I couldn't tell you how many times since 94 that I've sent misalignment through my vibration data collection to people. And then we have a conversation, and like you said, their eyes kind of glaze over when you're talking about the peaks, the 2 times, and they're just kind of ready for you to be out of the room.
How do I fix it?
That's right. Yeah. When you show them a motion amplification video, one thing about our videos is they can't be unseen.
Yeah.
Okay. So when your boss looks at this, or whoever it may be, they look at these videos and they see that foot lifting. They can't unsee that. It needs to be corrected.
Yep.
Right. Yeah. So it does help drive for that correction a little bit quicker.
Yeah. I see what you're saying. So it kind of inspires people to really hone in on it until it's fixed.
That's right. Yeah.
So it's the opposite of out of sight, out of mind, right?
It is. You get to actually see it. Yeah. On those subtle movements. Yeah.
No, that's cool. That's cool. Now, a majority of our customers are in that marine industry, and we're going to get into that a little bit later. But what would be some of the other industries where might use this technology?
Oh, wow. Yeah. So I use it as a hobby myself. Yeah. So I take it all around. I've taken it into the drag strip, got in with some of the drag race teams.
Okay.
I have shot DNA under a microscope.
Oh, wow.
DNA doesn't naturally move. They had it tagged to move, but they were having some issues in that project. And really, where we're heavy is in the industrial sector. That's kind of me playing with it, shooting a lot of different
Industrial
things.
sector being paper plants, power plants.
Oh yeah, anything that's made,
Water,
pretty much. Yeah,
water treatment facilities, stuff
That's
like
right.
that.
Yeah. Pretty much all of industry that has rotating equipment. Not that it has to be rotating. We shoot bridges as well.
Yeah.
On my trip over here, I stopped by a certain city that is having a little bit of an issue with one of their bridges, their drawbridges. Yeah.
Yeah. Don't mention that.
Yeah.
Don't mention that name.
I won't mention where it is actually, but yeah.
That's good. That's good. So what do you think is the most interesting problem that motion amplification solved for you in your experience?
Oh, wow. It's so vast. Really. It really is that I couldn't really pinpoint one thing. I will say that you will see misalignment like you have never seen it before, right? So I can see if someone has a video playing across the room and it's misaligned, I could tell from across the room that they have misalignment.
Oh, wow.
Just by watching the video. At that point, we do need to draw some regions of interest on the motor and say pump or whatever it may be. Pull out that actual data so you can quantify how much misalignment. Because we can show all this motion, we can also verify that you have a good alignment, not that it's just out of alignment, right? So is it 1 mil of misalignment and it's within spec, or is it 10 mils of misalignment and is it out of spec? Because we can amplify that motion, we can make things look like they are bad. So you do need to bring out your spectrum, your waveform or orbits to quantify what's going on there.
Yeah. Multiple different pieces of the puzzle to make the picture, right?
Oh, sure.
Yeah.
Yeah.
And just to clarify, we're talking mils as in thousandths, right? Thousandths of an inch, not
Yes,
millimeters.
1 mil is 1/1000th of an inch. Yeah.
Okay. Just want to clarify.
So Tony, I know you guys work in the marine side of things a lot,
Very much.
and have a lot of experience right there, especially with all technologies, but motion amplification in particular. Maybe share some of your experiences there on the marine side. Yeah,
absolutely. I mean, like you said, we're very heavily entrenched in the marine industry, and particularly coming from that vibration analysis side of things, right? So we're always looking for that next big thing, right? And when we found motion amplification and RDI, we were like, well, we gotta get in on that, right? It's pretty. I mean, we were blown away the second we saw it, and that's what prompted us to get it. We bought it maybe 2 months after we saw it. But to answer your question, I mean, yeah, like you said, there's a lot of applications for it. Preferably when there's more room in the engine room, but there's different mounting arrangements and brackets that you've thankfully assisted us with over the past few years. And yeah, I mean, we've been able to identify, like you said, there has been misalignment. More often than not, it's structural. So for one example, we were working on a hybrid diesel electric fishing boat out on the West Coast, and they had 5 generators that were running the propulsion system, and they kept cutting out when they got into high seas. So we set it up. We shot kind of like from what your guys' trainings we learned, you shoot wide and you hone in small, right?
Sure.
So we actually shot all 5 generators, and we saw that there was a problem on the number 2. So we honed in on number 2, and it was it's called a skid mounted system. So you have a generator and an engine, and it's mounted on one simultaneous base. And that skid was twisting. So we were able to see that, and it was another similar situation where the bracket was not providing enough rigidity to the actual skid. So yeah, then we found that problem, right? Honed in on it, designed a new bracket that added some transverse stiffness side to side to keep it from twisting and keep it straight. And that fixed the problem.
Is this the one you did the resonance test on?
Resonance test.
I was hoping that was it. Yeah,
No. That was actually the first one. We did a bump test on that engine to try and find that natural frequency. But we actually, you bring up another good one. We use this a lot to test natural frequencies in struts. So outside of the vessel, typically you've got a piece hanging down from the hull that the shaft goes into, right? It's usually an eye.
Okay.
So we hit the barrel and we watch how it reacts, and that plots out, our time waveform that and basically tells us what that natural frequency is. So Cory, why don't you tell me, have you seen many other maritime applications on your guys' end?
So we saw a few prior to you all just kind of taking it out, where we had not taken it before. So we've done quite a few things docked, but you all go out to sea, so you get a lot of experience right there for sure.
Yeah, more like, what's the term? Standard operating conditions.
Oh yeah.
Right.
Oh yeah.
Yeah. Because that's
totally
that's
different.
crucial. Yeah.
Yeah.
You've got static, and then you've got true operating.
That's right.
Conditions.
That's right.
And that was your guys' own research and development on those maritime applications, right?
It was.
Yeah.
Yes.
Yeah.
Yeah. But I would say I think pretty easily that you guys have taken it another step, a step further. For
Thank
sure.
you.
Yeah.
So yeah, and then the last application that I just recently completed myself personally, we were working on a tugboat, and they have a pretty intricate drive line. So they've got 7 bearings in between 2 cardan shafts, diesel engine on this side, and an Azipod thruster on this side. And it just,
No problem.
it goes up, goes up on an angle. So they've been having issues where their bearings are overheating, and typically that's a sign of misalignment, right? Because it's usually either your vibration or overheating. Overheating usually is the worst thing that happens, but say la vie. So we went out, we checked the alignment of the cardan shafts, and they were fine. And once again, we suspected that there might be some structural issues. So we actually paired up. This is one of those times where motion amplification and vibration analysis kind of paired in together.
Nice.
So we hooked up our, we have a 20 channel data acquisition system, does all 20 simultaneously.
Oh, wow.
So we hooked up sensors along all their bearings. And that was fun running all that cable.
Oh yeah. Yeah. Been there.
And then, we set up the camera, and we looked aft to forward to aft at multiple different locations. And what was is it the HDR?
It is.
Mm-hmm. HDR.
High density.
Yeah.
Mm-hmm.
So thanks to that, you guys just came out with that, right? That was pretty recent release, I think.
It's been a couple of years.
Okay.
Yeah.
All right. So thanks to that filtering, we were actually able to identify that the entire shaft alley was twisting. So this had 5 of the bearings in this one compartment. And what was happening is the structure was twisting, and that's causing, it's actually called dynamic misalignment. So you've got static misalignment, which is your standard, are the couplings aligned, offset, and gap. But then you have dynamic misalignment, which is when you check it when it's not running, as is standard practice, right? It's fine. Everything's fine. But because that structure is moving, it's actually forcing the bearings to go out of alignment while it's running.
Wow.
So that's what was causing this overheating issue. So we're currently working with the naval architect and the builders to try and beef up that structure for the next hull that they're currently building.
Okay, nice.
Yeah.
and can take that and probably duplicate it on like boats, right?
Yeah. Unfortunately, they were only contracted to build these 2. Okay. So they have this one that they have to fix, and then they have the other one that they're going to hopefully build, and everything will be running smoothly.
Okay,
after
nice.
the design
off of
changes.
your data.
Yeah, exactly.
Yeah, see,
Exactly.
that's a win, right? Yeah,
Absolutely.
That's huge. Yeah.
That's what we're here for. So, Cory, we've been primarily using your Iris M system, right?
Mhm.
That's kind of like the standard.
The workhorse.
Yeah,
Yes,
yeah.
yes.
That does 90% of most things.
I use that same phrase. Yes.
But I do realize that it does have kind of its limitations, right? So you can only get up to what was the max?
1,300 frames per second,
Frames per
which
second.
would give you a 600. Half of that would be your F max for your
650, right?
vibration. 650
Yeah.
hertz. Yeah.
So I mean that's great for low frequency, structural, misalignment, unbalanced kind of things. But what's going on? What would be the next iteration for your more high frequency stuff?
Okay.
Say blade rate for the propellers, or firing order for diesel engines and stuff like that, which is going to be at 5, 6, 12 orders of running speed.
Sure.
Yeah.
Yeah. So that would bump you up into the Iris MX.
MX.
Okay. So the Iris MX, we'll back up just slightly. The M is 2.3 million pixels.
Okay.
At 1,300 frames per second.
Okay.
The MX is 5.3 million pixels.
Much higher definition.
It is at 29,000 frames per second.
Oh wow.
So that resulting F max, half of that will be 14,500.
Wow.
Yes, hertz.
Yeah, that's high frequency. That's good stuff.
Yeah.
Okay. So you're almost getting into bearings at that point, right?
We don't do bearings currently.
Okay.
But yeah, I have been surprised through time with all the features that our developers in the development team, either off of customer requests or their own doing, as furthering the product with features. So
yeah,
I'm not going to rule that out, even though we don't currently do anti-friction bearings.
Research and development, right?
That's right. That's right. RDI.
Innovation.
Yeah.
Yeah, and I know like you and I are actually we need to schedule a sit down to go through using the TAC for like torsional stuff. I know that's I've been very interested in learning more about that. And then I know too the Iris M is kind of limited to that 2D frame, right? You get it in 2Ds.
That's right.
2 dimensions, sorry. Is there any plans or anything out there that is trying to do that 3-dimensional?
Yeah, so we do have stereo vision.
Okay.
Which is 2 cameras, one slightly pitched to give you that Z. So we measure in the X and Y currently. With the stereo vision, you can pull the Z data. You can't see the Z movement currently, but you can pull that Z data. So if you wanted X, Y, and Z simultaneous data collection, you would use the stereo vision.
Okay.
So if you think about coupling it to, we have a modal box now. It's called modal amplified.
Okay.
You can couple that stereo vision dual camera system into it.
Okay.
And then your tuned hammer out the other side. And when you bump it with the modally tuned hammer, then the response you get will be simultaneous X, Y, and Z data.
Okay. So clear that up for you guys. That's vibration analysis jargon for make things easier. Trust me when I tell you that makes things much easier. Is there anything that you could kind of share with us for what is RDI planning for the future? Do you have anything in the pipeline that you might be able to give us some spoilers on?
Yeah, great question. So I will first mention one of the things that we just released in April, because it's not widely known, I guess. If you have seen the Boston Dynamics robot dog Spot, we were approached by them because we are non-contact vibration using cameras, for a vibration solution for Spot. So we currently now have what we call the Iris Explorer, that is a payload for Spot.
Okay.
That is route based. So you plan a route for Spot to go around to different machines. You hit learn, and it can automatically go and run that route and take your motion application data for you. So that kind of rolls into our new release. Our next software release will be 3.7.
Okay.
Which will be set up more route based for people.
Oh, okay.
couple of nice things, features out of it is you think that we're a tripod, right? So how could you be route-based as far as getting that repeated data every time? There will be, when you set your camera down, you'll have your old distances, and there'll be an overlay on your screen where you can set your camera up exactly where you were before.
Okay.
Yeah.
So it kind of, it decreases the, what's the word I'm looking for? It makes it translucent, right?
It does.
So it makes the previous image translucent so you can line up the current image.
Yes.
Almost like a drawing.
It is.
Like a sketch.
You can bring out some other things to line it up. There's some edges as well that you can pull out. But yeah.
That's really cool.
Yeah.
That's really cool.
You know, a lot of people have asked about route-based stuff. And so we try to please our customers.
Yeah,
so,
absolutely.
So we have an email address, ideas@rditechnologies.com, that anyone can send a request of, hey, I think it would be great if the camera could do this. That's where we get a lot of these development ideas. We just recently, I say recently, a year and a half ago, put on a service division to our company, which is where a lot of people pull their research and development from their service side. We pulled all of ours from our customers and what their actual needs were. That's what drove the Iris MX. That's what drove the Iris CM. People wanting to know, they want motion amplification video of that bump in the middle of the night. And how that works is it will email you a motion amplified video at whatever time that actually happens.
Wow. That's so what do they use to essentially trigger that video? Is it like so much movement?
That's a great question. So you can use the virtual ROI, region of interest, like we normally do. So you can draw that on the box, and it runs, the Iris CM runs in a 90-minute loop, continually taking data off 2 cameras, right, simultaneously. So you can set up an alarm that sounds like this. When 1 mil goes up on the back of the motor, give me the data 3 minutes before it happened and 3 minutes after. So you can see what may have led up to that issue before it triggered the alarm. It could be a valve not moving or a valve moving, right?
Oh, yeah.
So we can bring in that 4 to 20 milliamp signal from the valve and also trigger off of it.
Oh, wow.
Yeah. So the Iris CM, and again, this was customer request this is one time where we will touch the machine. There is an accelerometer that can be coupled to the Iris CM and out to the machine.
Okay.
It's for triggering.
Okay.
The same way.
Got it.
You can also use a TAC. So TAC input, if speed changes up or down and you did not want that to happen, then you can trigger off of that as well. You can make a complex trigger where it takes in effect of all of these and their amounts and then triggers and fires each camera.
Wow. That's really cool.
It is it is a pretty powerful unit.
Yeah.
And it is, so the CM also, and this edge device that we're talking about that's about to come out, it's kind of the progression. So vibration came out, data collector, single point, people going around, right?
Yep.
So the progression of it was you have wireless sensors on everything feeding back that data.
Yep.
The same thing we're seeing with motion amplification. People take these single points, right? Just like the vibration, and it has matured into that CM, that continuous monitoring, this edge device, just like some of the wireless sensors that you see out.
Well, I know in a lot of the next progression of vibration is also the whole IIoT, the industrial Internet of Things. Is that kind of in your guys' realm as well?
Oh, sure. Yeah. We're always staying on the leading cutting edge.
Oh, yeah.
Or trying to be ahead of that as well. But yeah.
Okay. Sounds like you got a lot of really cool, innovative things coming up. I can't wait to get my hands on them and hope you'll reach out when they come out.
Oh yeah, for sure.
Well, just want to thank you again for being here and sharing your wealth of knowledge and experience with us. Really appreciate your time.
I appreciate AME. I appreciate the opportunity, and call us anytime.
Absolutely, will do.
Thank you.
Thanks a lot, Cory.
Thanks for listening in. We hope you enjoyed our deep dive into this week's tips and tricks for equipment optimization. Want to learn more? Head over to AME's LinkedIn, Facebook, Instagram, or YouTube included in the show notes, along with details from this episode. That's all for now, folks. See you next time.